coils got hot.
Well, they don't really. I mean, the point between the drawing bucket and the pyrocoil is really on the
just to get the wood chips
fence of whether you need it or not. So if you look at the one out there, you'll see that it has a piece of silicone in there. We're making a whole silicon gasket set for this, but the problem is the silicone is very limited in where you can use it. On the really hot stuff, you end up still having to use the tape.
Oh, yeah.
So, but there will be some more silicon gaskets.
Any questions?
About our academy or anything else we do?
I can give you some suggestions. I work with algae company. You know, so like you were saying, it's $33 per gallon.
That's the number we saw and looked up. And
Right. That's true because reactor cost.
yeah.
If you go to different reactor material and make thinner tubes, get to higher cell density, then eventually at also bigger scale. At this scale, you can't make anything. So you had to go to like thousands of acres to make price for $1.
Yeah, and when you get that big, you need to keep the contamination out.
Right.
You know, and so there was a lot of issues. We just like, we've been running on the wall. Let's try something else. Kind of
Yeah,
that way.
the pathway where it has the potential for working is open ponds, working with, my assessment, working with local species that don't have the contamination issues. Your production can be much less, but the economic and logistic realities of making purpose-made CO reactors is huge.
Right.
Might as well make a solar panel that's going to collect at a much higher efficiency.
Absolutely.
When you use biomass, you accept the relative inefficiency of biomass because it's free and it happens everywhere, ubiquitously. It self-manufactures, it self-reproduces. You don't have to build it. So the moment you start getting into purpose-building a solar collector, you're up against the fundamental low energy density of solar radiation. It becomes very difficult to build human structures in a manner that's cheap enough that you can harvest the solar energy expensive. So the photobioreactor stuff kind of combines the worst aspects of both biomass energy and solar purpose solar collection into a bastard.
We won't completely abandon it. It'll be maybe a 2 or 3 day lesson in the years to come. But
why not take the algae and pyrolyze it instead of trying to press oil out of it? Just pyrolyze it.
well, you got to get it dry, and so acres and acres.
Huge problem is
Dry it out. Yeah.
If you're doing it in the desert,
Well, yeah, we don't.
Where my camp is like, you can't monopolize too much land.
Yeah, you got a centrifuge to get it to 80% or something. I don't know.
There are some species that settle by itself. You let it stand without any aeration, it will settle out. But if you want to go to like 20% water, then you eventually have to centrifuge.
Right.
Getting some kind of filtration.
And the other processes that might be interesting with these are the hydrogasification processes, where you're working in supercritical conditions, very high temperature and pressure, going directly to liquids. Now, where you just take the algae.
That's pyrolysis.
Yeah, it's a pyrolysis process ultimately, but it's, you can have a little lab scale thing that you can run at the 2,000 or 3,000 psi to make these processes work. And you make that as a you're not going to make it as a personal scale. You might make it an industrial scale. So there are chemical and thermal pathways you can go direct from that algae to an oil.
Yeah, no, it's
efficiently. Then you don't have to dry it. So that's what's interesting in those is you run them wet. Okay, but you just run it in supercritical conditions, so that wetness is now.
Well, yeah, that trough that I mentioned actually showed some promise, being able to just get it to 250, flash it into a larger chamber. And then we were seeing the oil settle on top, but it was not much more than an oil slick.
So, yeah, so now you built two separate solar collectors such that you can run inefficient biomass.
Right, exactly.
Okay, so better just don't build any solar collectors, or build a really good solar collector.
See, that leads me to the question I wanted to ask you. A lot of the things Jim's talking about, and this is a direct question that you do to see if you understand. What Jim's trying to point out is there's no point in any of this if it's too expensive to do. Do you understand? So in other words, we can all talk about how fun it is to do this and how fun it is to do that, but you have to understand, and I just wanted to ask, do you understand that it's all about, can we afford to do this? Can someone afford to do this? Because if you can't, or if it's not, you know what I mean, then you just sort of spin your wheels. And so that's what Jim's trying to make sure you understand is it's no good unless you can use it and you can afford to use it.
Well, you know, we talk about petroleum, right? Why it's affordable? Because they are doing it at big scale. If they were going to do a small scale, it's not going to be affordable either.
But I think if you're thinking ahead about what you're doing and about we want to do green energy, but we can't afford to spin our wheels on something that will never be important.
But that's what they're doing here. I mean, they're going through all forms of power generation and conversion and seeing the benefits and liabilities of each one. Unfortunately, we don't have a silver bullet in this. We have a gigantic Vegas buffet of poor options. But there's a lot of them, and some of them are kind of intolerable. And each one makes you sick in a different way. So they're learning, the relative types of sickness that they can have while engaging in this problem.
But we also know that the way we've been doing it is a serious problem. So that's a big driver in all this.
Any to where we can drive away from what we're doing now and become greener helps.
So the stuff that the small-scale photobioreactor is relevant for is food. And the exotic interest, or the species that are interested in food for nutrition are often rather exotic, because polluted. But in those, the prices of them are many multiples above what their fuel value is. So, I mean, we had a whole algae container down here, but we did lots of algae across them. And it was done in half 55-gallon drums for propagating different species. And yeah, same problem. You can't really run it reasonably to get fuel, but you can run window scale photobioreactors for nutrition. So there's a website, algalabs.org, to make it happen.
Yeah, I was curious. The biomass you got from algae has inflation, which could get the water. Anybody you look at that as anything general?
We didn't get that far at that point.
It's fairly simple. Especially if you run it at varying temperatures.
Right, just some of the algae naturally produces methane, is that what you're talking about?
No,
The digestion.
Digestion.
Of the algae. Davis does that a lot in FBS, getting over there, talking to them before we started it ourselves. And I'm learning as I go here. My learning curve in the last 2 years has been huge.
it'd be something you guys could do like your laboratory.
Yeah.
Scale down.
The freshmen do that on a real small scale, using little biodigesters. But yeah.
Put it in there.
Yeah, definitely.
Are you finding other schools sort of adopting your model of energy?
What it comes down to is the teachers that are there, if they're interested in it, yes. But you can't take an administrator and say, we're going to study this if the teacher doesn't like it. It'll fall apart. So it becomes, and so there's a lot of people in the area that are green construction because some former contractors become teachers. There's some engineering programs that have become green because they were CAD and engineering and they're robotics. So it just depends on the teacher. So in my academy specifically, not too many people doing this. Some will incorporate solar panels and wind. Nobody's doing it in alternative vehicles as well.
How many other schools do you know that are doing it? I've never heard of another high school-based green academy. This is amazing. Are there others?
They're popping up. I think the CPA model, the California Partnership Academy model, there's probably in the state now 40 or 50 academies that are considered green and do something of this. I don't think there's any one academy that does everything we do, but they incorporate solar and wind.
Do you have conferences where the people that do these programs tend to gather?
Not really. They have the CPA conferences where they talk about helping at-risk kids. Because one of the models is 50% of our kids have to be identified as at-risk to start to be funded. So that helps out that kind of thing. But specifically to guide me in green, people are asking me. They think I'm the expert. I come from I teach AP physics. That's what I had been doing, and I like to tinker. So this naturally led into that. But no, there's nobody helping me really.
Well, this is amazing, you guys. This is really, really impressive. Most people that work in industry can't do what you're doing.
I think it's so cool what you guys are doing. And from the business perspective, research and development is never profitable. Only what comes out of research development is profitable. So as long as you're understanding what doesn't work and working and learning fatally fast and then moving on to see a new idea, you're doing the right thing. So very cool what you guys
They've
do.
seen a lot of So we got this many people here. I figured 2 people would show up.
Wow.
Thank you guys.
Not bad.
Thank you all.
Oh yeah, thanks guys.
So we take interns down here too. You want to send people down for weekends and weeks?
I think over the summer you guys should be right here.
If it comes to you to start setting up some of these offices, if it comes to you to start getting them,
I will see you day one.
Should they can fix the one he
Yeah.
has.
Hey guys, bring up the website for the academy from the website.
down there.
so we get them all together, then Jim can go for talks. Then they can get decks and you guys can all have competition.
Academies. Green Tech. This is our website that kind of tells us what we do. Can you get a little, can you go make it a little smaller, control minus or something? Can you do that?
That's just going to do the test.
What's that one's gonna do? Yeah. Anyway. Okay, just scroll over and maybe show them. We do a lot of this picture, scroll up a minute guys. Like that's Daryl Steinberg, my students have presented a bill in front of Steinberg. This is kids doing competition with wind. This is the bioreactor from last year. This is part of the compound that you guys saw. This is homecoming week and they're doing a solar trough there. Some kids competed with SMUD, our utility company, and some electric vehicles. But all throughout here it kind of shows who our sponsors are, things we've done. That's a Tesla. But this, if you guys are interested in what we do, you can go to our website here and all of this. Scroll up a little bit more, guys. And actually, it's a site as well. This is elementary schools. No, I'm sorry. Scroll over that way, left, right, whatever that looks like on your screen. No scroll bars. I don't know. So if you're interested in things we do, you can go with that. This was at the state fair. They took some of our projects. We have a solar ambulance, bicycle ambulance here. This is one of the solar vehicle cars they built. This actually, you guys remember green machines as kids?
Yeah.
You know what the green machine is? This one steers that way, actually. So they actually took that mechanism to steer. We took 2 scooters, and each team had 2 scooters, and cannibalized and made an electric vehicle out of it. So that's one of the wind turbines they built. I don't know. There's lots of stuff we do. Yeah, it's cool.
You go.
Thanks.
Yeah, so if you want us to come up and have it together and absolutely do things, that'd be great.
Once we get up and running, if you guys ever could come over and like look at it and what's what we're doing, that'd be
Well, the integration with the engine is going to be the most difficult part. So, like when you get to that point, we can come up with that and we can also bring the power pellets, how we see it together. There's many more of you than 6, right?
Yes.
Oh yeah, we have an entire class.
30 of us.
Only us could come to this today.
Okay.
So there's
Yeah. About 30 per grade level.
Okay. Yeah, we didn't do that much.
No, I didn't.
But if you guys come down, we'll make sure we have like more than just our academy. Because if there's other people from other schools and other academies that want to see what you guys are doing, because it's wonderful. You know.
Great.
We really appreciate it, guys.
All right. Thanks, guys.
Thank you very much. Appreciate it.
you guys.